Hello everyone. In this video and four other videos that I'm going to make under a new playlist called 3D printing, my hope is to provide you with a relatively good basis about what 3D printer is, the advantages and disadvantages of it, give you some new info you might or might not have about new trends and topics in the world of 3D printing, followed by technologies, review of technologies in 3D printing, some material used, some comparison among them, then get into more technical parts, talk about the 3D printing parameters like layer height, like support material, infill, shells, bridges, raft, brim, skirt, and so many other things, retraction, followed by some common errors or problems with the 3D printing files that would lead to bad prints, and finally with some of the common problems and failures that happen during the 3D printing and some potential solutions for troubleshooting. So please be with me in these videos and give me feedback. If you need to know about some further material, let me know and I'll try to provide you as much as my knowledge allows. So you might wonder, what is it so special about 3D printing that makes it such a huge growth and such a big market in the manufacturing sector? As you can see by this chart here, you can see in billions of US dollars. It was predicted maybe in 2014 that the total market of 3D printing will be like probably $3 billion. It turned out to be four. For 15, it was like a little bit less than 4 billion. It was a little bit more than 5. And you see, not only it is growing, it is actually growing fast, and it is faster than what they expected. So they expected, like by last year, that the total value of this industry be below 10, like maybe $9 billion, while it easily surpassed $20 billion worldwide. So it is going on a stable and very fast growth. And what is it that makes this such an attractive option for many people? So the major advantages are this. Faster development and modification cycles, right? If you want to make a part, as long as the material for that part can be used with 3D printers, creation of that part, especially if they are what? They are prototypes and draft ideas. If you want to get them into a physical object, maybe get them to some customers and get some feedback about, let's say, this beta version or prototype, 3D printing is the ultimate solution, because imagine like if I made some simple object like this, okay? And I want to create this and then give it to the user and get some feedback. Well, if I want to make this out of plastic, as I said, your solution is to go with, if you want a larger scale especially, is to go with injection molding, right, or other methods of mass production manufacturing. And not only, as we'll discuss in a minute, they are very expensive and they take a lot of effort and skills to make. The other problem is it takes a lot of time to make the molds for this, or if it's out of metal, you need a lot of time setting your CNC machine or any other tool to make that simple part, let's say, out of metal. But if I have this part, if I want to print it with, let's say, a plastic printer, all I literally have to do is to go and say, hey, file, save as, and then save it as an STL file, one of the common files that you see for rapid prototyping, like STL. And then if I go, let's say here to my Prusa slicer, all I need is to drag that file, import it here, and guess what? Once I have that part and I do some very fast settings on how much infill I want or shells or something, which should not even take, let's say I want it fully solid, so I just change it to 100%. right? And if I want support or not, if I want to change my plastic, if I want to change my layer height. Once I do that, which should not take even 1 minute, then I say slice. This is going to generate the G code that the 3D printer will read. Done. And then it gives me even a very good estimate of, hey, it needs 300 grams of plastic. If it's a regular PLA plastic, it's gonna cost you $7.7. It takes 12 hours to print and so on. You export this on a SD drive, micro SD drive, SD or any other type of medium that these printers would work, flash memory maybe. And then once you save this G code, all you need is to put that G code in the machine, click run, and there we go. And now if somebody says, well, why didn't you put the fillet here? Here you're gonna have a stress concentration, right? Then you go to here, right? You change this, you add some fillets. Again, you're going to what? Save this as the STL, right? And then again, go back to your slicer software, bring the new one in, and re-slice it, and again put it back into printer. Look, just like that. Here, that's your fillet here. So you see, changing something, adding something, and reprinting it is just a matter of seconds or minutes. Okay, if it's especially something simple. But can you redo the mold for this? Right? Or go and change everything on the G code of the CNC machine? It takes a lot more time to do that. So this fast recycling and modification and generating prototypes is the biggest advantage of the rapid prototyping, especially by 3D printing. Now, as I said, lower initial costs and accessibility to public, that's a big thing. In the past, 3D printers used to be really just for big companies. They used to be very expensive. But now these days, most of the kids even have it at their homes. All they need is probably spend $200, $300, buy some simple yet robust printers like Reality, or a little bit more, 800 for a Prusa, or a few $1,000s for better printers, right? But you can go as low as $200 or so for something that works quite reliably a lot of times. So it's very initial, a very, very low initial cost, as I said, compared to something like a CNC machine, which is in tens of thousands of dollars. And running that and maintaining that also needs a lot of money, or injection molding, which is really expensive. Even for a simple part like that, making a mold, right, will be a few $1,000s to a few $10,000, depending on the complexity of the part, whether it has cavities or not. And then if you want to do injection molding, you need to have the machine, or you need to pay to outside manufacturers for you to do anyways. In all of those, the cost is in terms of hundreds or 1,000 times more than a simple 3D printer, okay, which can deliver you the same plastic part, or even I'll show you, metal parts. So this accessibility, and the other thing is the amount of training that you need for a 3D printing and 3D printing jobs. Even by watching these videos that I'm doing, you should be easily able to do your print with Prusa. Okay, but and Prusa is not really the easiest printer. It's really meant for people who know a little bit about printing. You can use something like MakerBot or some other printers that's just like plug and play. Prusa, you need to know a little bit more. You need a little bit more training, which I'm going to give you in these videos. But once you do, it gives you a lot more capabilities. So, but comparing to running a CNC machine or doing injection molding, it's nothing. It's like bare minimum training that you need to have. Okay, so it's much easier to work with. And one of the biggest advantage for now, for the big guys, for the people who have money and they don't mind spending a little bit more, right? Big manufacturers, is not just that it's cheap or something, is that they can make parts that they used to be impossible for traditional or a single mode of traditional manufacturing to make them, or it was very hard and expensive, right? Just imagine parts like this one here, right? Brackets like this, some of the engine parts, some of the turbine blades, and so many other things that were very hard, sometimes impossible, even for a 5-axis CNC machine to make. Now, with the metal 3D printer, they can make these parts at a much, much cheaper price, and the complexity is unparalleled. As I said, you cannot do it on a CNC machine. That capability for these people is a big thing, that they can make parts they could not in the past. That's a big thing for them. The other thing is waste reduction and benefit to the environment. And here you might say, well, it seems like backwards to me, because 3D printers most of the time work with plastics. And when we 3D print, we have a lot of, most of the time, support material or something that we break and throw in the trash can. And that is going to add to the already huge pile of plastics on the planet. How does it reduce the waste? How does it benefit the environment? And you are right, as long as we are not using those waste for something else, or the waste made by other people, not just 3D printing, for some manufacturing purposes. That is one of the new trends and one of the new topics in 3D printing, is not only the plastics that are being discarded at the moment during the manufacturing by 3D printing process, but any other plastic waste, we can use them and repurpose them and reuse them in 3D printing again. And as I said, that's what you can see here is, you see bags of these plastics collected from all sorts of things, from home disposal to so many other things, industry. They are trying to repurpose them, and you see they have printed this big basically planter here. They 3D printed it from those wastes, and they're trying to plant something in it. So recycling plastics and repurposing them for 3D printing can really benefit the environment and come up with less waste instead of more. So that's in terms of benefit to the environment. And also open source print files. We're going to talk about that, but there are so many open source print files that are available, and you can use them, and they are free, so you can just go and because not always you are creating something new. Many times you want to create a part, and that part that you want to use, you do not want to reinvent the wheel. Your goal is to really go ahead and create the part that you need as soon as possible, as cheap, as fast as possible, without redesigning everything from scratch. And there are, as I said, so many open source print files and websites that you can go and download these files from, and they're free. You don't need to even pay any membership premium on something. And you might say, like what? Let me show you. So one of the greatest, I can say probably the greatest, the largest collection of these files is the GrabCAD community. You can freely join this group, and they have literally millions and millions of files on most of the thing you can imagine. You can just search them here, right? You want a bolt, you just search a bolt. You want, let's say you want to print the body of a drone, you just search the body of a drone. They have CAD models in all sorts of software, the print files and everything. And people have already shared this with others, free collection, and you can download them and print them. You don't need to start from scratch for many things. Now, I know many people here talk about the copyright problems and so on, but that's not really my concern at this moment. I'm here just to show you the resources, and I'm not advertising in favor or against anything. I'm just telling you, I know that's one of the issues that they always mention, copyright in 3D printing, but again, my goal here is pure educational. I'm not advertising anything, but you clearly can see you can save a lot of time, a ton of time. If you want parts that have already been 3D printed and somebody's 3D printed them, so they are definitely working, you don't need to do a lot of checks on them to make sure they are printable or not, then you can go to Thingiverse, which is by MakerBot, right? This GrabCAD is supported by Stratasys, really. Prusa has its own models. Now, it's not as big as GrabCAD or Thingiverse, but clearly you see they have right now 57,000 files. And they have printed them already. So this is like Thingiverse. Thingiverse has a lot more files as far as I know. They have a lot more files, and GrabCAD has millions of files. That's as far as I know. If you go and look at them, it says over several million files that there is, right? Let me see if I can bring the first page. Here you can see it has close to 5 million free CAD files, okay? And as I said, all sorts of things, components, assemblies, there are tons and tons of components free that you can easily just join this website and benefit from all this. So this is a huge advantage for people who don't want to necessarily make a patented product. They want to just use something for their own personal use or in a minimal location in their overall product. So now it looks all amazing, all good. It is clearly having a lot of growth. And you might say, well, with that huge amount of possibilities that you can see here, why isn't it bigger than this? Why isn't this technology has gone to be the ultimate and the only solution in the world of manufacturing and taken over all other modes of manufacturing and be the like the only manufacturing mode? Well, because it has some disadvantages and some cons too. Like what? If you want to do large scale manufacturing, the process of 3D printing is slow. So you clearly see that this part, now not that this part is small, no, if you look at the dimension of this, the diameter of it is about 4 inches and the height of it is about an inch. But if I have this part molded, creating a part like this will be just a matter of a couple of seconds or so probably. So the plastic goes into the mold and is formed and then released by one of those springs out of the mold, and then the next one, right? So in a day, you can have thousands of this with a single injection molding machine, right? If not millions, definitely thousands of this part can be made in a day with an appropriate mold and injection machine. You definitely can do that. But if you have a 3D printer, you definitely see that the time for this was about 12 hours or 13 hours in this case. So even if I can squeeze 4 of that on a plate, still it's going to be like 3-4 hours per each. Okay, so if I want to produce this part with 3D printers, I need what we call a 3D printing farm. You need tons of 3D printers to be able to match one single injection molding machine. And you might say, well, the injection molding machine is not as cheap as the 3D printer. So for the price of injection molding machine, you should be able to buy lots and lots of these 3D printers and do the same thing. Well, you might be able to, but it's not just the print speed that is the only limitation. And plus, not everybody has the room and the capability to maybe run 100 3D printers at the same time. The room that they take is a lot more than a single injection molding machine, okay? So this is not really meant for large scale manufacturing, but they are working on it so fast and significantly. There are big work on it right now. There are industrial level printers that can produce a lot of similar parts in a day. in with a single printer. So their print volume, and that's item number 5. Most of the regular printers that we have as hobbyists or people who want to learn about printers and work with them, they are small print size. So you can clearly see in a Prusa, right, the print volume is about 25 centimeters or 10 inches, and this is 20 centimeters or 8 inches, and the height of it is again something similar, 8 to 10 inches. So at best, it's not even 10 by 10 by 10 inches. It's not even 1 cubic feet. Okay, so the print volume of that is small. Now, if the part I want to print is quite bigger than that, in any direction it's about a feet, even just a feet, and then there is a small chance that you can even fit it diagonally. You have to break it into pieces and then assemble them together, which makes the part definitely weaker. But as I said, there are more and more large scale industrial 3D printers that are coming to market, and they're trying to be used as a main mode of manufacturing, not just creating prototypes. So they're working on this and they're improving. And the same thing for item number 5, as I said, limited build volume. The other thing is material. Well, most of the time, what you see coming out of 3D printers is plastic. And even not all plastics, but a lot of plastics these days. So when it comes to other material, 3D printers are not going to be used for all material. And you might say, what about metals? Can I print something with metals? Well, absolutely. There are metal 3D printers. And as I showed you, and we're going to see in the next video, these metal 3D printers, which use technologies that we call powder bed fusion, like SLM or SLS, they can print metals for you. Of course, the process is not so fast, and these machines are very expensive. These SLM machines typically are $500,000 to $1 million and up, and running them needs quite a bit of training. They are not as simple as running a Prusa, but yes, you can do metals. But again, can I do every single metal that is in the market? No. For example, when it comes to, because they work with powders of metals, when it comes to powder of metals, one of the things is some of these machines have a hard problem with aluminum, because the powder of aluminum can easily be set on fire. It's very volatile, and some of them are working very well with stainless steel, some of them even with titanium. But they're increasing the range of metals that they can print. And you might say, what about ceramics? Well, they're working on it. There is some progress in that area, but still there is a lot to be done. Mostly the material are plastic, but there are all sorts of plastic, and we're going to talk about them. Some of these plastics have very impressive performances, okay? They can do not identical, but they're getting closer and closer to actual metals. Plastics, high performance plastics like PEEK and Ultem. There are resins that are used for medical applications, and the range of the material that you can 3D print with these days is increasing, but still you have a bunch of material, right? Like actual wood or something like that, so many other metals that still there are limitations, but it is growing. The other big thing that I mentioned was it's not just the size and the speed of the printing that matters. One of the problems with 3D printing is the material are anisotropic, especially with the most common technology of 3D printing, which is called fused deposition modeling, or FDM. What you do is you print the material, and we're going to discuss it in the next video, layer by layer. And these layers are just cold welded. They are just sitting on the previous layers. So the material is not really homogeneous. As you can clearly see in this image, the material is definitely not completely what? Homogeneous. And that makes the strength properties of the plastic to be weak in the direction of the print. So if you are putting these layers up on the top of each other in the Z direction, in that Z direction, the strength of the part is not so good, and these layers can easily come off each other, which we call delamination. Okay, so this anisotropic properties, not material being not homogeneous and weaker in one direction compared to other direction, that is a big disadvantage. And still that problem exists, I would say. The progress that 3D printing has made in that area is far less than the other areas so far. There are some talks about annealing 3D printed parts, but because plastics are not easily annealed and you cannot do a lot of heat treatment on these anisotropic, the fusion of the layers together will typically cause deformation of the printed parts and loss of tolerance. So that's a very hard area to improve easily. A couple of other things that I need to mention. Let me first go to item 6, need for post-processing. And again, it goes back to this same thing. If I print something like this guy here on the right side, definitely the surface finish of the part is not really pleasant and nice. So many times I need to do what we call post-processing of the part, right? And try to basically do sanding, do painting, use epoxy, use acetone, and so on. Use electroplating, which we're going to see in the next video, and try to make this rough surface that is right out of the printer into something that is a lot more acceptable for even something that is decorative, not functional. So many times you need to do post-processing. And finally, this is another big area, is lack of sufficient monitoring and maintenance systems. And for those of you who use 3D printers a lot, or are just recent users to the world of 3D printing, especially before you get enough of training, you find that your printers tend to fail a lot, right? You see, hey, my printer is stuck again. The filament is stuck in the nozzle is clogged. The layers are not aligned well. There are so many modes of failures. We're going to talk about them that you will see. There is material oozing. There are all of these stringing going on, and so on and so forth, right? The part doesn't stick to the bed. There are so many modes of failures. And before you get proper training, these problems, each and every one of them has to be handled. And for somebody who does not have enough of training, it could be quite frustrating that you have to deal with all of these problems. You have to, because it's a new technology, have to learn a lot how to fix this problem. And once you get rid of that problem, a new problem shows up and so on. And that's because, again, the cheaper 3D printers that many of us work with for hobby and learning, they are not really meant for using and all the time and producing large scale number of parts. So if you keep printing with them, the rate of failure of components is pretty high because their monitoring systems and maintenance systems are not so strong. And you probably have seen, you have some big prints that is going to take 1 day or 2 days to print. And initially it's very good, and you cannot sit there, watch the print all the time. So you leave it and go, and you come back after a few hours or maybe a day or something with the hope that the print is going fine as it should. And then you come and you see a big fluff of plastic and a failed print that has wasted your time, your money, your everything. And if it's for a real production purpose, right, which is time sensitive, that is not going to be good. And these failures make many people that are not tech savvy and are not willing to learn and are not willing to work with the new technology like this be frustrated with using 3D printers over the time and say, hey, I would rather do my traditional manufacturing. So these monitoring systems that check whether a printer is failing, and if it does, then it stops the print or raise some alarm or inform you or something. still in the infancy time, and there has to be a lot of work done in that area to make these printers more autonomous. So you just click on start and you go, and once you come back, you have your final product. Not constantly keeping an eye on them and making sure that it doesn't fail. And if it does, sometimes there is nothing that you can do. You have to, again, start the print from scratch. So still a new technology, still there is a lot of way that we have to go before this becomes like the most dominant thing in the industry, but you clearly see the growth is really, really fast and stable. So this is just the beginning thing about why 3D printing is important and so on. Now, some of you might be bored at this point and say, hey, this guy is just talking about some of the stuff that I already know. So let me tell you a few other things that might be more interesting to you. One of them I already covered, and that is there are tons of print files in so many repositories on the web, like Thingiverse, GrabCAD, and Prusa, that you can get all of these files for free. So I absolutely recommend, if you are using a 3D printer and you are not using these websites, go ahead and look at them and sign up for them and get to use their tremendous amount of interesting parts. Now, some interesting areas that the 3D printers have come to work in and generate products are, other than plastics and metal, is one of them is food 3D printer. And this is one of my favorite areas. There are now food 3D printers. They are used in some of the restaurants even around the world, and they can generate some specific types of material, right? This frosting, creams, chocolate, pasta, and some soft material. And they give you some 3D printed edibles with all sorts of nice shapes. That is really interesting. So you can look at some of these printers. One of them is called Foodini. It's like the magician Houdini, but changed to Foodini. It's just $2,000. There are some cheaper versions too and more expensive ones. But this is an area that is quite interesting. Another area is still the world of plastics, but these printers, which we call polyjet printers, they can print multicolor, multi-material parts like this anatomical models that you can see here and so many other functional parts. So they are made of so many different colors and also different materials at the same time. And they make so much nice parts for so many purposes, including education and so on. So these polyjet printers are something nice. We talk more about them in the next video, but these multicolor, multi-material parts are very interesting. Another interesting area is clothes. They have started working in the clothing industry, and now you might wear your 3D printed clothes. Now, still in its infancy, but it is growing, and I'm predicting that soon you're gonna see a lot more 3D printed clothes, or you might be able to 3D print your own clothes and not go to the store to buy that. Now, of course, it takes some time. Of course, not every plastic that you print is safe to touch your skin. They have to be specialized plastics, but it is getting there. Okay, right now it's mostly for fashion industry, but ultimately I'll see these guys coming to people's homes, especially the clothes and the food. So now some more high-tech emerging topics and current topics that might be interesting to you. One of them that is my favorite really is the concrete 3D printers or house 3D printers. So it's more than just house. So these printers work with the same technology, but instead they are using specialized kind of concrete, and they can print structures like houses, like small structures. They are not yet producing super large structures, unless they are huge robots with huge booms or huge gantry robots. Most of them are limited to smaller sizes, but now they are changing their size of them, and they are making all sorts of concrete buildings and structures at a very fast pace and much, much cheaper than what you see in daily life. So they can make a concrete small house, the structure of it only, not anything else, just the structure of it. They make that in sometimes in about 24 hours, and at a price that is like 1 to 5% of a regular house that, for example, here in the US you make out of wood. They make it out of concrete for you, so stronger. It doesn't it cannot get on fire, right? Much faster and much cheaper. So this is going to, and there are big works on it right now. This is going to revolutionize the construction industry, especially for houses and structures. And there are so many people working on this concrete. This is, as I said, a specialized type of concrete. It has its own problem, but they're working hugely on it. And this is one of the areas that is my favorite. Another area that I saw people are working on it is what we call actual or contour 3D printing. So as you know, a 3D printer goes layer by layer, and I will explain that in my next video. But an FDM printer, it goes one layer, one layer, one layer along the height direction. So it lays down the material along X and Y plane, then goes to next Z level, does the same thing, goes to next Z level, does the same thing, and goes up layer by layer. Okay, and that makes this kind of ugly, rough surface finish that you'll see, unless you make the layer height very small, which basically makes your print time a lot larger. So one of the things that they're working on is, during the 3D printing, the head of the 3D printer does not stay at the same Z and does all the deposition of plastic on that XY plane and then going to next Z, which by the way we call 2.5 axis machine. What it does actual 3D motion. So the plastic can lay out something at a specific Z on the XY plane, and then without finishing that XY plane and going to another Z, immediately it can move to another Z level and lay out plastic. So while it is working, it can move along X and Y as well as Z at any time point, okay? And it's not limited to staying at a fixed Z level before going to the next one. So it follows the contour lines of the object, and if you do that, that makes not only your print faster, it definitely makes it a lot smoother and nicer looking, as you can see here. Right here, you see all of these steps, right? And these edges, right? Which are for small slopes, as we're going to talk about in video number 4. Some of the problems with print files is small slopes and stepping. So you clearly can see that here, but by following contours, you see much nicer and smoother print. What else? As I told you, the world of injection molding is right now is the standard method of manufacturing for large scale production. And the molds that we typically use these days are made out of aluminum or other metals, because they can withstand temperature, they can withstand pressure, force, and they're durable, okay? And plus their melting temperature is way higher than the plastic that is going inside them. So they are absolutely suitable for injection molding, the molds to be made out of metal. But the fact is, making these molds out of metal and CNC machining them is the big cost and portion of the cost of injection molding. Molds are very expensive to make. So now they are trying to make the molds for many plastic parts out of other plastics. And how do they do that? By 3D printing them. So now they are trying to 3D print molds. And here you can see these two white parts that are molds for this purple part. they are 3D printed out of a resin, and that resin has a higher temperature, quite higher temperature than the actual plastic of the material, this purple one. And although they cannot work for thousands of prints, there are thousands of molds, I'm sorry, or injections. So their range of being used is way less than probably hundreds or tens of parts, but still they are way easier to 3D print than to do mold like this, right? You need very advanced CNC to make all this stuff. But with 3D printing, you can make these molds very fast, very cheap, and you can repurpose them and reuse them. So they are getting into the area of 3D printing molds for injection molding. Okay, and this is a big hot topic these days. I told you about the repurposing and recycling plastics, not only from the 3D printing itself, but from all other waste of plastics that we have on the planet. They are trying to make them into smaller pieces and then remelt them and repurpose them for 3D printing again. And this recycling plastic for 3D printing is another big area. What else is a new area? This is another one of my favorites here. It's called volumetric 3D printing. And what this one is instead of, because as I told you, the 3D printing process is a slow process in general. It takes a lot of time. Especially one category of it, which is called SLA or stereolithography resin printers. These guys are quite slow, although they can give you amazing surface finishes. But these resin printers are typically very slow printers. Now there is a new category of these guys coming in to the research area, which is they're trying to cure the resin by projecting different patterns, which are different angles of the same object from different directions. They are basically shining the UV laser at the resin from different angles, but different patterns of it, which are like different views of the same part. And while the resin tank is spinning, right, these guys also spin with them. And at the same time, all of these different projections, they will cure all of the part in one single time or at the same time simultaneously. So a part like this, for which the resin print, based on the current technology, layer by layer or pixel by pixel, that takes so many hours, now can be made in matter of few seconds or 10 seconds or so. And I've seen videos of that. If you want, I'll put some links in under the description of this video, and you'll see that people now, they are working on the resin printers in a few universities like EPFL and Berkeley, and they are trying to print resin objects made of resin in matter of a few seconds instead of several hours, called volumetric 3D printing. And this is very interesting area, can revolutionize the world of 3D printing, because that removes one of the big obstacles of printing, which is a slow process. The other thing that might look for many people like a sci-fi, but it's absolutely not, is printing implants and live cells. Okay, so now they are trying to use this technology and print live cells and implants for people, like the outer part of the ear, like skin, some other parts and members of the body. They are trying to 3D print. So 3D printing live cells, that's the huge thing in the medical industry. So you should not, if you want, let's say in the future, a part of your body, you should not wait until somebody donates it or somebody dies and they give it to you. Okay, there is going to be in the future the chance that maybe not you immediately, but you need your ears to be basically changed, the outer part of your ear, because something wrong has happened to it and it's not working. You can get that to work. Okay, So they might just get some of your cells and they're trying to reproduce an organ or a small part of an organ for you. They're working on it. There is big research going on. And another one that I saw recently and I really liked is rockets. Yes, they are actually 3D printing the entire rocket these days into one single piece instead of so many pieces with so many joints. And joints are always the places of defects. Joints are the weak parts of the components, large components like this rocket. That's where most of the failures are happening, most of the leakage are happening, and so on. So now they try to print this whole huge rocket in one single piece using 3D printers. And yes, this company is a startup and they have produced using their largest metal 3D printer in the world that they have. This is a startup company. You can see they have made their huge rocket just in one single piece using metal 3D printing. So this area is absolutely revolutionizing manufacturing and the capabilities of us human beings on what we can do. So hopefully this video, this introduction was a little bit useful to you. As I said, in the next video, I get to talk about technologies, common technologies of 3D printing, common materials, followed by then some terminologies of 3D printing and some practical things about how to troubleshoot some common problems. And then during these videos, I will also show you how to work with the Prusa slicer, okay? And finally, I'll move my camera from the screen to the Prusa I have at home, and I'll show you how to work with the Prusa original i3 in practice. Okay, so my goal is not just to inform you, but also basically doing this as like a training course on 3D printers. So please be with me for the next few videos and I'll try to teach you most of the stuff that I know and I have knowledge about in the world of 3D printing. Thank you so much for your attention. I will see you in the next video.